Approximately 400 years ago in the spot, a well was excavated to provide the people of James Fort with potable water. After a few short years of use, that water went bad, forcing them to excavate another well elsewhere. They filled in this well, and in doing so, they filled in several objects 14 feet below the surface of where I'm standing now. One of those objects, a Roman lock pistol, would prove to be one of the most challenging and interesting objects in my conservation career. The pistol was complete with a wood stock, copper alloy barrel, iron lock plates, and lead shot. In this Dig Deeper episode, we're going to cover the conservation of that pistol. "16 years ago, archaeologists excavating in the spot recovered that Roman lock pistol. That started my long journey in the conservation and preservation of that pistol to actual public display. What started as a muddy, wet mass became the center of a new exhibit in the Archaearium. Let me take you now from the site of recovery to the site of conservation. So we're in the Archaeology Conservation Lab at Jamestown, where a lot of the magic actually took place with the pistol. Say the first time that I saw the pistol, I was working at Colonial Williamsburg as an archaeological conservator, and the pistol was recently excavated and brought into the lab, and I saw it sitting on the counter, and I thought, wow, that thing is incredible. The first thing I did is took my camera out and took this image. This is the earliest image that I have of this pistol, thinking that was probably the last time I will actually see this pistol. So 2 years later, Emily Williams, my supervisor, presents me with the pistol and says, okay, you're going to be working on this now. The excitement that came over me for working on this really incredibly interesting and significant object, it was just absolutely incredible. But then the fear set in. What am I going to do to conserve this pistol? It's made of wood, it's made of iron, it's made of lead, the shot, and the barrel itself is copper alloy. I had to come up with a plan to treat these objects in a way that would mitigate damage to the other components of the pistol. That's because some of the steps required to conserve the pistol will help some parts of it, but will actually damage other parts of it. For instance, the polyethylene glycol, which is great for the wood and bulking of the wood, will actually corrode the iron components of it. I had to make a decision. What was the most important component of this pistol? I decided it was the wood, because that is so rare to find in archaeological context. The first step that I took was the removal of the iron corrosion product overlying the wood. There's certain treatment choices that you have, and you have to make a decision based on how much damage you're doing versus how much good you're doing. Conservation is often a fine line between that. In this case, I decided to go with an air scribe that's like a little micro pneumatic hammer. And using this air scribe, I was able to bust up a lot of the corrosion on top of this wood, and a lot of it that was also on top of the iron lock plate. Because the pistol came out of a well and was waterlogged, perhaps the most challenging aspect of the conservation treatment was keeping the pistol wet while getting the work done. Every 2 minutes we had to dip the pistol back into deionizing water to ensure that the wood wouldn't dry out, but also to mitigate potential corrosion of the metal as more oxygen was reaching the metal surface. So once we removed the iron corrosion crust from around the wood stock, we had to remove the iron corrosion crust from the actual iron lock plate. Here I had to make a choice. My go-to method is air abrasion. Now this is using really small particles of aluminum oxide to basically sandblast the iron corrosion off. But realize that that powder gets everywhere. And this wood in a waterlogged state would eventually be dried, and when it was dried, it would probably shrink and some of those iron oxide particles would be trapped in there. So I decided this is not the method to take. So I went back to the air scribe, and we worked several hours on the lock plate to reveal the various components, the machinery, the working parts of the lock plate. But over time, we started to hear a little bit of rattling from within the barrel. Now, earlier x-rays showed that there were 2 lead shot in the barrel of the pistol, meaning it was double loaded. We knew that that was what we were hearing, those two lead shot rolling around. In order to remove them, we had to take that air scribe to the muzzle of the pistol to remove a little bit of the copper corrosion and a little bit of iron corrosion on the muzzle, thereby opening a passageway for the two shot to roll out. It was as simple as that. While using the air scribe on the iron lock plate, we noticed that around the flash pan, the magnetite was very thin and friable, and we felt that we needed to preserve that aspect of the pistol, that component. And so we used epoxy resin to fill up the small voids in the flash pan to secure that magnetite surface. After tens of hours of working on this object, other priorities popped up, and we knew we had to store this object in a stabilized way. We put the object back into the deionized water and put that tub of water into the refrigerator to keep it cool, to slow down chemical reaction rates. I thought I was actually never going to see the pistol again, because shortly thereafter I actually went off to school. After graduating, I was asked to come back and to continue my conservation work on the pistol. So I came in, this is 2020, I came in and started with making mylar drawings. Now mylar is a thin plastic. I was tracing the various fragments of the pistol, mainly focusing on the wood though. And in this way, I was able to record the dimensions of each of those wood fragments prior to a future treatment process where I'm going to dry the wood. And in that drying process, the wood is expected to shrink. And this is the only way that I could make or show the amount of shrinkage that had happened. Very shortly after there, COVID struck and the lab closed down for a better part of a year. I found myself coming back in towards the end of the year, and the first thing that I did, pulled out the pistol again. And having removed that corrosion crust from the pistol, you could see where the corrosion crust used to be. The wood, the waterlogged wood, was stained an orangish color. That's telling me that there are iron oxides still within the wood. And if I was to dry the wood in that state, those iron oxides would certainly cause damage to that wood as it dried, but could also cause future problems. So it was my duty to remove as much of that staining as possible. Plus, it's just more aesthetically pleasing to the eye. And to do this, I used a chelating agent, but I'm not going to go into chemistry here. I think it'll suffice to say that I used EDTA to remove this iron staining. And the results of that, when I used this poultice, you could look at the poultice and see this bright blue color on it. That didn't quite make sense to me at first because I was trying to remove the iron staining. What I realized is that, of course, the copper alloy barrel, there are a lot of copper ions in that solution, and I'm pulling the copper ions out of that, not the iron ions. So I went to another chelating agent, a much more stronger one, sodium dithionite and ammonium citrate. And the results of that, I actually saw a lot more of that red color coming through on the poultice, which was excellent because that meant I was actually removing the iron staining. And that was such a sense of elation. Oh my goodness, we're avoiding a future issue here by removing this material. So knowing that the pistol was double loaded, I knew that there was still probably black powder, a black powder charge in the barrel. A little bit of it, we were able to recover a little bit of it the decade prior, but I knew there must be much more there. We were able to retrieve 4 vials of the black powder. Showing 3 here because one's actually on display right now. Having removed the black powder, I then made a social media post, which you can go to, where I'm actually sending an endoscope, a little tiny camera, down the barrel of the pistol. It's really cool, you should check it out. But then we had a happy little accident, not so much with the iron lock plate, but with the copper alloy barrel. After having worked with it for quite a while, I started to notice that it was actually becoming loose when I was handling it. Yeah, at first I was like, oh, what have I done? But then I realized, no, this will actually serve a better, this will actually serve the pistol in a better way. With a tiny bit of work, I was actually able to remove that barrel, which meant the barrel I could treat separately, I could dry it separately, and I could start work on it immediately. So having removed the barrel, I could now see the underside of that barrel. And there was one little spot of corrosion near the breech. Taking the air scribe to that corrosion and popping it off revealed a nice brassy sheen to the pistol, and reminded me, even though I wasn't there for the initial excavation of the pistol, I had seen the videos and the barrel was shiny at that time. Then looking back at my photograph, my personal photograph that I took of the pistol, I saw that the barrel in that photograph also showed some very shiny areas to it. Now, when you look at this photograph, this is shortly after the barrel was removed, you can see how the barrel has corroded. Now that's something that we see a lot in archaeological conservation. When objects are in the ground, they reach a state of equilibrium with their environment. Most of the time, that means that they corrode much more slowly, or in some instances, stop corroding completely. The most damage that happens to archaeological objects is right after they come out of the ground. They're suddenly exposed to a lot more oxygen in the air, and that accelerates the corrosion process. So this barrel that was almost completely shiny when excavated, within 3 years was a copper green color. I conferred with some of my colleagues at the Mariners Museum, and they suggested this concoction. Again, it's an EDTA poultice, but the poultice itself looked kind of like shaving cream. In fact, they call it shaving cream. And so on this part of the barrel that the public will never see, the part that actually sits inside the pistol body itself, I put a bunch of dollops of this poultice on there for experimental testing. To make sure that I wasn't over cleaning the object, to make sure that it was going to work with the barrel. When I found a time period and the right consistency of the shaving cream poultice, I applied it to the barrel as a whole, well, actually to sections at a time. And that, along with a little bit of light brushing with a glass bristle brush, really brought out the brassy sheen to the barrel again. Well, I hope you're enjoying this, but you've only heard half the story. So stay tuned for our next episode where we cover the remainder of the conservation of this pistol.